Hello, welcome to another video of the Solidity Do-It-Yourself tutorials. In this video, we are going to talk about structures. What are structures? Structures are those data elements, data sets that can contain data with multiple different data types or same data type. So let's see how a structure is formed. So you would write struct transaction. So I'm going to use structure to create a transaction or multiple transactions. So structure string from name. So where did this come from? The amount, and then this is the ending. So structure transaction from an amount. So if you look at our use case, we're going to mimic a bank transaction. And in this transaction, we for now have only two variables, string and unit. Think of that as a structure, two column string for from name and UN256, the amount. Now let's start filling the transaction. In order to do that, what we can do is we can say that we got transaction from Jeff Bezos. So let's see how to do that. For that, we will do transaction and then public transaction struct. So I'm going to create a transaction struct, which is going to be a type transaction, which is the structure, equals transaction. Or I'm going to create a new transaction. I'm going to say string, which will be from name. So assuming I'm going to get it from Jeff Bezos. So transaction, square bracket, the curlies, from name, which is the first column, Jeff Bezos. I'm going to put hook comma, and then I'm going to define amount 25. And I'm going to close the braces and followed by a semicolon. Now, similarly, I'm going to do it for transaction structure 2 and 3. 2 and 3. The second one is from Bill Gates, amount 50, Tim Cook, amount 75. Now, I can add as many as transaction structures I would like, but is this the best way to do it? Can we do it more in a dynamic fashion? Let's talk about it. So for now, we are going to use this, and I'm going to say public, go to compile, say compile, go to the deploy piece, remove, there is no existing contract, so I'm going to deploy that. It's deployed. This is my contract. And then I see here, so transaction struct. This is transaction structure 2 and 3. So you can see the transaction. But what if there are 1,000 transactions? What if there are million transactions? Am I going to create million transaction structures like this? Probably not. In order to avoid this, we are going to use arrays. So let's do arrays. Now, in order to make it a little simpler and keep it very, I'm going to remove the public from here in these two transactions so that when I deploy the contract the next time, at least only one structure shows up here, but not the structure 2 and 3, just for the simplicity's sake. Now, what I'm going to do is I'm going to create an array of structures. So I'm going to do transaction. So if you look at it, I'm almost copying this piece. So transaction, you see I'm adding here square braces. This means it's an array. So transaction array, I can define number 2, 3, 4, whatever I want here in order to limit the array. But here, this is a dynamic array declaration. But there is no transactions in transaction list. This transaction list is an array of structured transaction. I repeat it one more time. This transaction list is an array of transaction structures. You can also create structures for uints, bool, string, and stuff only by pushing two square braces, and it forms an array for you. Next, I'm going to create a function that pushes transactions on this array. So function add transaction. Add transaction is going to be a function. String memory. And for now, I'm going to keep this memory piece aside because I'm going to come back to it and we'll talk about it. So function add transaction is a function to add these transactions onto this array. String memory. So memory is a keyword which tells me or tells the program that this from name is going to be stored in memory. Uint does not have this memory. We'll come back to that. Public, and here I'm going to say transactions list dot push. This transaction list, which is declared as an array of transaction structures, dot push is the function, is the method. Transaction from name, whatever the name I'm going to provide, and the amount. And I'm going to close the bracket. Now let's deploy this, and we'll come back and we'll talk about the memory and others. So I go back here, compile, come back here, deploy the contract, and you can see that I have add transactions over here, and then there is a transaction call. This is the transaction list, which is public, and this is add transaction. You can also see for helper functions, I need to type the name and the amount. Just to be consistent on these transactions, I'm going to type Jeff Bezos, 25, add transaction. You can see that it would say the transaction has been added, Jeff Bezos, and amount 25. And if I go here in transaction list, if I type 0, which is the 0th index, and I'm not going to talk about array index, but index starts from 0 and goes up for every record 1 up. So 0 is Jeff Bezos. If I type 1, I haven't done the story yet, but there is no answer, right? There is nothing there here. So I'm going to type another one, Bill Gates 50. So I'm going to type Bill Gates 50, and I'm also going to do Tim Cook 75. Tim Cook 75. And now when I say 1, it will say Bill Gates 20, and the second index would be Tim Cook 75. So what I have done is created an array for dynamic. Now, just wanted to know that there are the functions. There are 3 types. The types are Calldata, memory, and the storage. So there are 3 types of storage functions, identifiers that tells the program, Solidity program, what kind of storage I want to use. Now let's see what is the difference between these. The Calldata, so you can, instead of memory, you can write Calldata. It is also a type of storage. But when I compile it, it's going to give an error. The reason it's going to give an error, let's do that. So if I compile it, it's obviously not going to work when I say Calldata from name. If I want to change, it won't let me change here. The reason Calldata will not work, and it seems to be compiling properly, but it deploys as well, but Calldata is not going to work because it is a temp variable that cannot be modified. So I cannot have from name and change from name. So for example, if I type here underscore from name equals blockchain. So I cannot change the call data here because call data is a temporary variable that cannot, oops, sorry. So let's redo compile. So it will say that type literal blockchain is not implicitly convertible type string call data. That means this call data does not allow changes to the name. And because we said, if I just say memory here in terms of call data and then compile, it's not going to give me an error. So memory and call data are temporary variable assignments or storage assignments that can be modified when you say memory and cannot be modified when you say call data. Storage, which is the third form. So this variable is a storage variable. That means it's a permanent variable that can be modified. I repeat it one more time. Call data is a temp variable definition that cannot be changed, cannot be modified. Memory is a temp variable like call data, but this memory variable can be changed. And finally, storage is default is a permanent variable that can be modified. So these are the differences between call data, memory, and storage. Now, in the next video, we'll see the details on how do you write some complex functions on Solidity. I hope you're enjoying this series. Keep watching.